Hello students, I'm going to review one of the structural elucidation exercise which I gave the two classes last week. I think for one of the class it's given as exercise 3, whereas for the other class it's a group exercise. There's a bit of a difference between the questions which I gave the two classes. I think the bulk of it lies in paragraph 5. Yeah, but it doesn't really matter because the review of the whole exercise will remain the same because the letter unknowns remains unchanged. Yeah, so if it helps, you may just want to pause for a while to re-look at the questions and then maybe work through on your own and think about what are the possible letter unknowns. Yep. Okay, so right now I'm just going to go through with you the main information. Right, so for compound P, you were told that the molecular formula is C10H18O. So if you do a quick calculation on its degree of unsaturation, I think you will get a value of 2. Yeah, so 2 degree of unsaturation tells you that it either has 2 double bonds, 1 double bond, 1 ring, or 2 rings. Okay, then after that, we look at the next paragraph. You were told that P does not react with 2,4-dinitrophenylhydrazines. So that means that it does not contain a ketones or aldehyde. Yeah. So for the normal way of presenting your answer, what you should do, maybe I'll use the blank page. What you should do is you should have observations. You should just tabulate your answers. So you should have observations followed by deductions. Okay, I think I've given some of the way of presenting your answer. I've uploaded the answer on Google Classroom. You can go and take a look. Yeah, but over here, because I'm reviewing how to go about working on the questions, I will not attempt to write out all the observation and deduction. I'll just be talking about it. Yeah, but for presentation purposes, for assessment, it is good for you to tabulate observations and deductions so that you are able to get the relevant credit in case you are not able to get the final structures. Yeah, anyway, there are marks allocated for the deductions portion. And for deduction, normally we are looking for a few things, namely looking out for the key structural features, i.e. the functional group, or let's say if it gives you a positive aldoform test, that will be the structural features having R, C, H, OH, and CH3. Okay, having these particular structural features where R is either a H or LQ, or it could be a ketone as well, or I mean ketone meaning a double bond O. Okay, so all these things I think it needs to be mentioned, as well as the types of reaction it undergoes. Yeah, so for this particular review, I will not be talking about it. I will only be talking about it. I will not be writing them down. So do bear with me on that. Okay, so I'll just be summarizing it for you over here. Okay, so we have P over here. It does not reacts with 2,4-dinitrophenylhydrazine, DNPH, so no PPT. Okay, and then but reacts with hydrogen and a palladium to give Q. So you notice that from P to Q, right, there is an increase in 4 hydrogens. Yeah, so that means that potentially my P contains 2 CC double bond. Okay, I can say for sure it is CC double bond in this case because the earlier clue tells us that it does not react with 2,4-dinitrophenylhydrazine. Okay, so that's why I can say for sure that it contains 2 CC double bond. Okay, so in this case hydrogen in palladium. Yeah, the molecular formula for P is C10H18O, and then after that Q, I'll get the formula C10H22O. Okay, and then after that I'm being told that Q reacts with ethanol chloride to give R, but is not oxidized by warm acidified potassium dichromate. Okay, so this particular portion, right, it tells us that P contains a tertiary alcohol. Why does it tell us that it contains a tertiary alcohol? Because number one, right, it's able to react with ethanol chloride. What is ethanol chloride? Ethanol chloride is the more reactive version of ethanoic acid, yeah, which allow reaction with alcohols to give an ester. Yeah, so from here I can also conclude that R is an ester. Okay, and the reactions between P and ethanol chloride is condensation reaction. Okay, and because it's not being oxidized, therefore it cannot be a primary or secondary alcohol. Okay, so this is a very important clue. I will not attempt to write down everything. Okay, so from here I will just jot down some of the important things I've taken note of. P, so it's a tertiary alcohol. Okay, and of course it contains 2cc double bond. Okay, and then moving on, with co-KMNO4, right, P gives S. Okay, so now let us take a look at the difference in the molecular formula. So if we compare P and S, okay, you'll notice that there is an increase in 4OH. Okay, just look at the molecular formula below. Okay, so there's an increase in 4OH. Yeah, so this is a further confirmation that P contains 2cc double bond. Yeah, because the reaction with co-acidified KMNO4 is what we call mild oxidation. Yeah, remember from your alkenes chapter, there are two forms of oxidation with KMNO4. One is oxidative cleavage, when we subject an alkene to hot acidified KMNO4, and then the CC double bond will break. Yeah, another type of oxidation which we are familiar with is mild oxidation, where usually we use cold acidified or cold alkaline KMNO4, where across the double bond, the pi bond is gone, and then each of the original sp2 hybridized carbon will now be bonded to an OH group. Yeah, so this further confirms that P contains 2cc double bond. Okay, and then next, P reacts with one con H2SO4 to give a mixture of T and U. Okay, so this is a very interesting clue, which I think when a lot of students try to attempt this particular question, you miss it out. Yeah, so what kind of reaction is this? Okay, so this is very important, so I'm just going to write it down over here. Yeah, so when it reacts with con sulfuric acids, okay, I end up with this particular T and U. Okay, so I'm end up with T and U. So both with molecular formula C10H16. Okay, so T plus U, so C10H16. Okay, so this is C10H16 as well. Okay, 16 as well. Okay, so I'm just going to box them up so that we know that we are talking about different compounds here, although they have the same molecular formula. Yeah. Before we move on, we need to understand what kind of reaction is this. Okay, so this is actually a dehydration. Okay, so in particular is dehydration of a tertiary alcohol. This is very important because we need to understand that T and U, both compounds, right, comes from the parents P. So therefore, T and U must share the same skeletal structure. They are only different in the way the pi bond is being formed. Yeah. So let me repeat. T and U must share the same skeletal structure. The only difference is that the CC pi bond will be at different position, and only one CC pi bond will be at different position. Okay. The remaining 2cc double bond must be at the same position because the original 2cc double bond comes from P. Yeah, so it doesn't make sense when the 2cc double bond are at different position. So this is something you have to be very sure about before you move on, because if you are not, then likely that you will screw up later on. Okay, so people just take note of this. Okay, so next we're going to move on with the rest of the clue, which tells us about T and U. Okay, so you notice that this particular paragraph tells us about T. Okay, and then the following paragraphs tells us about U. Okay, so let us read on. T reacts with hot acidified KMnO4 to give us V, W, and X. Okay, most importantly, we need to take note that T and U contains 10 carbon each, and then for V, W, and X, if you just do a quick count, total of 9 carbon. That means that 1 carbon is missing, so the missing carbon is likely to be due to the production of CO2. Okay, so that's very important. You need to remember it at the back of your mind, because if you don't, then later on when you try to work out the structure of T, you might end up giving unreasonable structures. Yeah, so in the process of strong oxidation, T must give off 1 equivalent of CO2. That means that T contains 1 terminal alkene. So that's also a very important clue which you need to be aware of. And the next line tells us that V and X both gives yellow PPT with aqueous alkaline iodine. So that tells us that they contain the methyl ketone as the important structural features. Why is it that it must be methyl ketone but cannot be say methyl alcohol? Yeah, as I mentioned many times in class, under oxidative cleavage condition, having methyl alcohol is not possible. Remember that, because alcohol will be oxidized anyway. Okay, so with all this, I'm just going to summarize it over here. Okay, so I'm just going to arrow downwards. Okay, so as we have seen, right, so T undergo oxidative cleavage. So I'll just put a O here. So to give us V plus W plus X. Okay, then the molecular formula is C3H4O3. So C3H4O3. W is C3H4O4. C3H4O4, and then X is C3H6O, and then V and X gave us iodoform test. So I2NaOH warm. Okay, so same warm, and then iodine and sodium hydroxide warm. Okay, so CHI3 CHI3. Okay, so from here we can easily sketch out a structure for V and X. Why is that the case? Because number one, they do not contain too many carbon, so only 3 carbon. So for example, for X, it has a degree of unsaturation of 1. So therefore, if I have 3 carbon and I must have methyl ketone as the structural features, then the only answer I can have is propanone. Okay, same case goes for V. Having 3 carbon and I need a methyl ketone as part of the structural features, then the other end containing 1 carbon, it must be a carboxylic acids. Okay, so it has no choice. Yeah, so usually after oxidative cleavage condition, we expect structural features such as carboxylic acids and ketones. Yeah, and then for W, I think we were given this particular clue. 1.104 grams of W requires 20 cubic centimeters or 0.1 moles per dm cube for complete neutralization. If we do a quick calculation, you will realize that W is a dicarboxylic acid. Yes, and same case with only 3 carbon dicarboxylic acid, so it has only this particular features or these particular structures. Okay, so dicarboxylic acid, both right at the end. Okay, so if nothing goes wrong, these will be the 3 structures for V, W, and X respectively. Okay, then some of you might be thinking, can I just join them up in any way I want, or in any multiple ways I want to get T and then work backwards? Yes, that could be a strategy you might want to follow, but do take note that oxidative cleavage of T gives 3 products, V, W, and X, but oxidative cleavage of U, okay, in the next paragraph, 4th paragraph, gives only 2 products. Yeah, so it's actually easier for you to work out a potential structure for U rather than you working out a potential structure for T, because once you work out a potential structure of U, then you can perform some elimination and narrow down your option to get your unknown for T. Okay, so now let us try to work out the structure for U first. Okay, now we were told that U being subjected to hot concentrated acidified KMnO4, we are able to get X and Y. So Y has the molecular formula C5H6O5. Okay, so I'm just going to continue from here. So again, I'm just going to write short form, strong oxidation. Okay, and I'm going to get X and Y. So X is C3H6O. Actually, we already know the structure of X, which is the propanone. Okay, and then plus Y. So Y's molecular formula just now we get C5H6O5. Okay, then after that we were told this particular interesting piece of information. When subjected to sodium boron hydride in methanol, Y gives Z. So if you look at the molecular formula, you'll notice that there is an increase in 2H. Yeah, so therefore from here, right, I can sort of conclude that Y contains a dicarboxylic acid and a ketone, because only ketone can be reduced by sodium boron hydride in methanol. Okay, and true enough, the last statement will be able to confirm our prediction, because when subjected to lithium aluminum hydride and dry ether, Y gives A, and then and you notice that A is fully saturated. So how do we know it's fully saturated? We just use the formula to calculate the degree of unsaturation, 2n plus 2. So that's 5 times 2 plus 2, 12. 12 minus 2, 12 minus 12 is 0. 0 divided by 2 is 0. Okay, so A is fully saturated. A contains a chiral carbons. Okay, so with that, we can make some prediction about Y. So Y contains a ketone and 2 carboxylic acids. Okay, so from here, right, because we know that Y must be fully or rather after reduction by lithium aluminum hydride and dry ether. So maybe I can write that out first. Okay, so after reduction by lithium aluminum hydride and dry ether, right, I'm going to get C5H12O5. Okay, and then I'm being O3. Okay, and then I'm being told that it contains a chiral carbon. So what are the two possible structure for A, which you can think about? What are the two possible structures? Yeah, so maybe you can ponder for a while and try to sketch out on paper. Yeah, so having 5 carbon, I can have straight chain. That's usually what students love to draw. Yeah, so if I have straight chain, if I put an OH here and an OH here, okay, that's symmetrical, right? Yeah, so if I put an OH in the middle, I will not have a chiral carbon. So the OH cannot be in the middle, so therefore the OH must be at one of the either at carbon 2 or carbon 4. So in this case, carbon number 2. Yeah, so this could be A. Yeah, another possibility for A, right, would be something that is branched. Okay, so maybe something like this. Okay, where I have an OH here, which is a chiral carbon, and then I have a primary alcohol here, and a primary alcohol here. 1, 2, 3, 4, 5. Yeah, so these are the two likely structure for A. With one chiral center. Yeah, but only one of them is correct, because as we read on, right, you'll notice that more clues is being given to you. Okay, so the fifth paragraph is the slight difference between the questions I gave the two classes. Yeah, because for those of you who did it in class as a individual exercise, you do not have a paragraph 5 because it's made easier. Yeah, so but for those of you doing the group exercise, I tweak it a little bit so to add a little bit more depth to the question, so that there are more thinking involved lah. But the thought process in getting the final product remains the same lah. So I hope you will bear with me for that. Okay, then for the fifth paragraph, Z reacts with warm concentrated sulfuric acid to give B with the molecular formula C5H6O4. First of all, paragraph 5 starts with Z. Okay, then we need to ask ourselves, where is Z? Okay, so Z comes from the reduction of Y using sodium boron hydride over here. Okay, so that means only the ketone is being reduced. Okay, so with that, based on the two structures I have drawn, right? Okay, so these are the two potential candidates for A lah. Okay, so that means that I'm able to predict the two potential candidate for Z. Can I say that? Because the two potential candidate for Z depends on A. Am I right to say that? Because A and Z comes from Y. Okay, so if that confuses you, then maybe I shouldn't put Z first lah. Okay, if that's the case, maybe I should just put Y. Okay, so therefore the potential structures for Y will be as follows: like this, okay, like this, like this. Am I right to say that? And then for the other candidates, it will be like this. Okay, so I hope you will agree with me on that. Okay, and then therefore the structure of Z after reduction of Y using via sodium boron hydride will be this. Okay, OH and then OH double bond O. So carboxylic acid will not be reduced by sodium boron hydride. Okay, so these are the two potential structure for Z. Now the differentiating part is in the next line. Okay, so the next line is extremely important. If you miss that out, then you're going to get the whole question wrong. B, demonstrate cis-trans isomerism after it is being dehydrated by corn sulfuric acid. Yes, so let us try over here. So if I dehydrate this Z via corn sulfuric acid, potentially, right? Okay, potentially I can exhibit cis-trans isomerism. Am I right to say that? Yeah, so I can have this is the trans, and then the other one will be the cis. Okay, so this will be the cis. 1, 2, like this. Okay, so we have the 1, 2, 3, 4. Yeah, so this is the cis, this is the trans, this is the cis. And for our case, for the other possible structures, I will not be able to have cis-trans because the same group, which is carboxylic acid, is bonded to the same sp2 hybridized carbon. Yes, so with that, I can straight away conclude that all these are incorrect. Okay, so all these are incorrect. Yeah, so that means that the correct structures for A, Y, and Z is as follow. And then, of course, you were told that one of the isomers, when continuously heated, you get C, which contains a 6-member ring. Okay, and then so between the two, only this can potentially gives me the 6-member ring upon cyclization. Okay, so in that case, I'm going to draw out the structure. So it will look like this, like O here, and then like this, double bond O. Okay, so this is what's the alphabet? C. So this is C. Okay, so this is C. Okay, when it's continuously heated. Yeah. So do you notice the kind of skills you require for structured elucidation? That means that you have to be very sharp in the way you analyze the data and then eliminate the other possibilities when there's a need to. Okay, so after working through all this, we finally get a structure for Y. Okay, so maybe I can redraw it over here on the left hand side. Okay, so I'm going to redraw it. Okay, so the structure of X is like this. So this is X, and the structure of Y is like this. Okay, sorry, double bond O. Okay, so this is the structure of Y. Okay, and then I'm going to number the carbon because as I mentioned to you many times, numbering carbon often helps and help us to do wonders like 4, 5, 6, 7, 8. Okay, remember that U after oxidative cleavage, right? That's U. After oxidative cleavage, it gives us X and Y, and then of course plus 2 CO2, which I did not write earlier on. And then earlier on for T will be plus CO2. Okay, so that means that T contains 2 terminal alkene. And sorry, U contains 2 terminal alkene, and T contains 1 terminal alkene. Yeah, so these are very important information. Yeah, so from here, right, from the structure of X and Y, you can sort of arrange them in such a way that you are able to get 3 possible structure for U. Okay, what do I mean? Okay, so for example, right, I can have C2 and C4 having the CC double bond right at the start. Okay, so therefore a potential structure for U will be like this. Okay, so I'm going to get this and then double bond, and then 6, 7, 8 and double bond. Okay, can you see that? Okay, so that will be 1, 2, 3, and then 4, 5, 6, 7, 8, 9 and 10. Okay, so this is a potential structure for U. I just call it U1. Okay, because it need not be the actual structure. Okay, and then alternatively, I can have C2 with C4. Sorry, C2 with C5. Okay, so if it's C2 with C5, then I'll have a double bond right at the end, and then like this, and then 6, 7, 8, 9 like this. Okay, so I'm going to have okay, so I'm going to have this is 4, 5, 6, 7, 8, and then 1, 2, 3, 9, 10. Okay, or alternatively I can have C2 with C8. Okay, so that will be like this, and then like this, and then 6, 7, 8, and then like this. Okay, that will be 4, 5, 6, 7, 8, 1, 2, 3, 9, 10. Okay, so these are the 3 possible structures, so I just call them U1, U2 and U3. Okay, now some of you might be thinking, then in that case, can all the 3 be correct? Not really. Yeah, you can't let all the 3 be the correct answer. The reason is, remember that based on our earlier story, right, T and U, both of them comes from P, and P is a tertiary alcohol, and there are 2 CC double bond that's already present. So that means that if I'm going to follow the same story, right, T and U must have the same structural features. Okay, that is very important. They must have the same skeletal structure. They only differ in the position of the CC double bond. Okay, and at the same time, you must be able to postulate a structure where you can have a tertiary alcohol in P. Okay, so let me just illustrate one example for you. Okay, so I'm just going to let's say I'm going to use U1. Okay, most importantly, I need to use U1. Before I'm going to use U1 or U2 or U3, I also need to bring you back to the earlier example on T. Okay, so if you look at T, right, upon oxidative cleavage, you notice that X is one of the potential structure. Okay, so that means that I will need to keep this particular end intact. So this end has to be kept intact. Do you know what I'm trying to say? This end has to be kept intact. Yeah, so for me to keep this end intact, right, that means that I can only play with another carbon that can potentially have a tertiary alcohol, and upon dehydration can give me T and U, where after oxidative cleavage, I'm able to get 3 products and 2 products respectively. Yeah, so these are some of the clues you need to take note of lah. So yeah, so with that, let us try to work with U1, and then you will know what I'm trying to say. Okay, when we start to work with U1, right, we'll notice that 1, 2, 3 must be kept intact. So 1, 2, 3 is kept intact. Only carbon number 5 can potentially have the, or can potentially be the tertiary alcohol, if you know what I'm trying to say. Okay, so that's 1, 2, 3, 4, 5, that's 10, 6, 7, 8, 9. Okay, right? So this is a potential structure which is P1. Okay, and let us try. If this is P1, right, upon dehydration, okay, using corn sulfuric acid, U1 is one of the products. Then what about T1? Okay, can I draw a T1? Okay, so I can easily draw a T1, which is like this. Okay, and then I'm going to number the carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then I'm going to try to do oxidative cleavage. So if I cleave here and here and here, I get 1 CO2, which is carbon number 9, and then carbon 1, 2, 3 will give us X, okay, which is this. Okay, and then carbon 4, 5, and 10 will give us V. Do you notice? 4, 5, and 10 will give us V. And then carbon 6, 7, and 8 will give us W. Right? Yeah, so that's perfect. Yeah, so therefore, U1 is one potential structure for U, and of course, it's linked to T1 and P1. So that's perfect. Okay, so this will be one of the answers I'm going to quote and draw at the end of the day. What about U2? Okay, U2 is impossible. It's an impossible structure, so I'm going to strike it out. Why is U2 an impossible structure? Because if I do not want to change carbon 1, 2, and 3, right? And as I mentioned earlier on, they must be in that particular position. There is no way I can postulate a tertiary alcohol out from the remaining carbons. Okay, you might be thinking, can I do it at carbon number 5? You can't. If you don't believe, you can try. So after you do that, you realize that you will never be able to get a T which can satisfy oxidative cleavage to give V, W, and X. Yeah, so if you don't believe, please try it on your own. Okay, what about U3? Okay, U3 is possible. Again, I can have a tertiary alcohol at carbon number 5. So I'm going to do that. Okay, so oops, I'm going to use red. Okay, so I'm going to do that. So carbon number 5 will be a tertiary alcohol. So 6, 7, 8. Okay, like this. Okay, so that will be 1, 2, 3, 8, 7, 6, 5, 4, 9, and 10. Okay, yep. So with that, this will be my potential P3. Okay, P3. And then what about T3? Can there be a T3? Yes. Okay, so oops, sorry, there's a double bond between 10 and 4. Okay, so therefore for T3, it will look something like this. Double bond here, double bond, and then 6, 7, 8, like this. Okay, I'm just going to put in the rest of the groups. 1, 2, 3, 8, 7, 6, 5, 4, 10, and 9. Okay, so let us try. Upon oxidative cleavage, C10 will give us the CO2. Okay, if I cleave over here, this keto carboxylic acid will be V. Okay, and then if I cleave here, 1, 2, 3 will be the propanone, which is X, and 6, 7, 8 will be the 1,3-propane dicarboxylic acid, which is W. Yeah, so that's perfect. Okay, so that will be the answer at the end of the day, which I'm going to propose if I'm going to draft my answer out. Yeah, so the corresponding U1, P1, and T1, and then correspondingly U3, P3, and T3. Okay, I think that should be it. I have already suggested 2 possible structures for T and U, and a possible structure for P. and I have explained all the chemistry involved and the thought process in getting the final answer. So if there's a need to, please see me for consults, or if not, then review the videos again to get maybe a slightly more clearer thought process, or you can review it again and again to try to think what I'm thinking, and so that it's easier for you to come up with the answers in the future. Okay, so with that, I thank you for listening, and I'm going to come up with more videos for structured elucidation in the future.